This is the solution of the activity 2, where you have to send some random temperature from the Arduino, process that in the Raspberry Pi so that you can choose to power on or power off the LED if, for example, you can power on the LED if the temperature is too low. So let's start with the Arduino side once again. I'm gonna remove that. So I already have this, okay, unsigned long last time action done. I'm gonna remove this and just rename it last time. Let's say temperature sent, okay, which makes more sense. And then I'm gonna do temperature sent delay. And let's keep 1 second, okay? So now void loop, unsigned long, we get the time now with millis, and we check if the time now minus the last time temperature sent is greater than temperature send delay. And in that case, we don't forget to update the last time temperature sent to the time now. So basically this here, this code here is gonna be called every 1 second, and we don't block the void loop with the delay. So to get the temperature, I'm gonna do int temperature is equal to, and let's use the random 5 to 25, okay? Let's remove that. And what we're gonna do now is we're gonna send this to the serial. So I'm gonna do in the void setup serial.begin. So same code, and then while serial like this. And here I can do serial.println with temperature. All right, let's actually test this code. So I'm gonna do upload activity 2. Done uploading. And how to test this code, I just open the serial monitor and let's see what we receive. 12, 12, 14, 18, 23, 15, 17, 9. So you can see it's correctly working. We receive a random number between 5 and 25 every second. Okay, so the first part of the Arduino code is done. Now in parallel, so I say in parallel because we're gonna do the 2 actions one after the other, but very fast, so it's just like we are doing them in parallel. I'm gonna do if serial.available is greater than 0. So if we have received some data, what we're going to do is the same thing we did in the previous activity. So I'm gonna do that very fast. String command is equal to serial.read string until \n with 1 single quote, and then if command is equal to on, we are going to power on the LED, else if command is equal to off, we power off the LED, and then else we can process the other command and, for example, print an error or something like that. Okay, now for the LED, I will need to initialize the LED. So let's create a define LED pin 13. Here, let's do, so I can do the pin mode before or after serial, it doesn't really matter here. Pin mode LED pin with output, and here I do digital write LED pin with high because we power on the LED, and digital write LED pin low because we power off the LED. Okay, so we have this action and this action running separately. As you can see, here we send data with serial.println and we receive data with serial.read string until, but the two are not directly linked. Okay, we don't just send data when we receive data. Okay, we have separated the two actions. Let's upload this code to the Arduino. Okay, and what you can do, for example, is you can just open the serial monitor. You're gonna see that you receive some numbers, okay? And let's just give on, and let's see that the LED is powered on. Okay, that's working. And as you may see, the random here is maybe not that random because we have the same data as before. So you could make it more random, but I'm not going to spend time on this. Okay, that's outside of the scope of this course. If you want, you can search more about this by yourself. All right, so the Arduino code is done. Let's go to the Raspberry Pi side. Okay, so we read from serial and we receive a number. So if we want to read from serial, what we are going to do is to do if ser.in waiting is greater than 0. And here, no parentheses, okay? You have parentheses here with serial.available, no parentheses here. So if we have received something, then we read that thing, okay? So let's say temperature is equal to ser.readline dot decode with UTF-8 and RS-strip. Okay, so the same thing we did before. So we read the line, we decode it because here it's bytes, so we decode it into a string, and we remove any other special character we have at the end. And what I'm gonna do is I'm also going to cast this into an integer. Okay, because, well, we want to process the temperature as an integer, so I'm gonna cast it as an integer. And to do that, I simply do int and I put everything in the parentheses. And now, if temperature is strictly lower than 15, let's say, then we are going to power on the LED. Okay, so let's put a comment here, power on LED, and then else. So basically, if the temperature is greater or equal than 15, we are going to power off LED. So let's actually do a print temperature lower than 15, LED on. And here, print temperature greater actually than 15, LED off. And then, of course, we send the command. So the command is still on and off, okay? So ser.write with on and \n dot encode with UTF-8 like this. And then I'm gonna copy this here in the else, and instead of on, we send off. So as you can see the structure here, so we continue with our while true, so the infinite loop. If we have received some data, we read that data, so we cast it as an int. So here it's very important, as you see here, that we also have defined a protocol. The protocol is simply that here we send the number, here we receive a number. Okay, and here we send on and off, here we receive on and off. Okay, so on both sides we know what we receive and what we send. Okay, let's now try this code. So it's already uploaded on the Arduino. I'm gonna run that on the Raspberry Pi. So activity2.py, it's gonna be added automatically. And let's see what we get. Okay, you can see that when the temperature is lower than 15, we have the LED on, and when the temperature is greater than 15, we have the LED off. All right, and that's the end of this activity.